Alright, hey guys, so we are going to talk about how to solve some of the problems on that worksheet, specifically number 5, C in acidic solution and A in basic solution. We're going to do C first because acidic solution is slightly easier than basic solution. So to start off, at 5C, and here is the equation. Here's the equation. 4,5C, it goes HCOOH plus MnO4 minus reacts to form CO2 plus Mn2 plus. So first thing we do, step 1, is we split them apart into half reactions. So this thing is one of the half reactions, so it goes HCOOH reacts to form CO2, and the other half reaction is these two. So that one's over here, a little space, MnO4 minus reacts to form Mn2 plus. Okay, so the first thing we do is we balance the non-hydrogen and oxygen things. So this one is just carbon, so carbon's already balanced, we don't need anything there. This one is manganese, manganese is already balanced, we don't need anything there. The next thing we do is we balance the oxygens by adding water. So we got 2 oxygens on this side and we got 2 on this side, so again we don't really have to do anything. But on this side we have 4 oxygens and no oxygens, so we need 4 waters in order to balance the oxygen. So now we have 4 oxygens on this side and 4 oxygens on this side. So we balance the non-hydrogen oxygen stuff, then we balance the oxygens, next balance the hydrogens. So there's 2 hydrogens on this side, so we need 2 on this side. And there are 8 hydrogens on this side over here, so we need 8 on this side. So now the hydrogens and oxygens are balanced. So the next thing we are going to balance is the charge. In this way, when you do the charge, you don't actually have to figure out which thing is being oxidized and by how many and which thing is being reduced, right? You don't have to be like, okay, the carbon is going from a +2 state to a +4 state, and so that is what, losing or gaining electrons, and how many electrons is it losing or gaining from +2 to +4? That is losing 2 electrons, and then manganese is going from a +7 state to a +2 state, so that is gaining 5 electrons. It gets rid of that whole step. You don't have to figure out if it's being oxidized or reduced, and you don't have to figure out the electrons. When you just balance the charge, it takes the electron, that step out entirely, the oxidation step out entirely. Okay, so let's balance the charge. We got no charge over here, nothing is charged on this side, and we got 2 positives, we got 2 H pluses on this side. So we need 2 E minus on this side. So now the charge on this side total is 0, and the charge on this side total is 0. Over here, a little bit more complex because we have lots of charged things. So here we got 8 pluses and 1 minus, so total we kind of got +7 over here, and over here we got +2. So to make these two equal, we need 5 more negatives on this side, or we need 5 fewer positives. So we need +5 E minus on this side. Hopefully, if we've done this correctly, the electrons will be on one side for one of the half reactions and be on the other side for the other half reaction. So in the products on one and for the reactants in the other. Now we need these 2 electrons to be the same. If they're not the same, they will not cancel out entirely, and we'll have electrons in our overall reaction. We can't have electrons in our overall reaction. So to make them the same, we need to multiply by the least common multiple or whatever, just add some factor to make them the same as each other. And so to multiply this, we need to multiply it by 5, because the least common multiple of those 2 is 10. So we multiply that entire thing, the entire half reaction, by 5. And then this one, we need to multiply the entire half reaction by 2 to give us 10. So that becomes 5 HCOOH reacts to form 5 CO2 plus 10 H plus 10 E minus. And this one becomes 10 E minus plus 2 times 8 is 16 H plus 2 MnO4 minus reacts to form 2 Mn2 plus 2 times 4 is 8 H2O. All right, now we're going to put them back together. Now that everything is balanced, we're going to put them back together. Now, even before we rewrite this, if we decide to rewrite this down here, we can cancel out the electrons. They're the same, they're in the reactants and the products, we can cancel those out. So now, we're going to write everything in the reactant side over here. So we can start off with our 5 HCOOH, and that's plus, and it doesn't really matter what order you write them in, and some people insist that you have to write the hydrogens first, whatever, I don't care. And then we got 2MnO4 minus, and that's all that we have on this side, for the reactants. Now the products, we're going to write those. So we got 5 CO2s plus 10, is that right? Yeah, 10 H pluses plus 2 Mn2 pluses plus 8 H2Os. That's what we had in the products. The electrons have already canceled out. Now, at this point, if there are things on both sides, we can cancel them out, right? If we have things on both sides. We got hydrogens and we got hydrogens. We shouldn't have hydrogens on both sides. So let's cancel out the ones that we can. So we got 10 and we got 16 hydrogens. So these go away entirely, and this is reduced down to 6. So we can just change the number, or we should cross it out and do 6 hydrogens on this side. So if you wanted to rewrite the whole thing, which I know that you do because that's how you are, you got 5 HCOOH plus 6 H plus 2 MnO4 minus reacts to form 5 CO2s plus 2 Mn2 plus 8 H2O. And that is it. That is your final answer for the balanced. Now that's balancing it in acidic solution, and that's why we had H pluses. It's okay to have H pluses because it's in acidic solution. These are available, or they are able to be produced and in there. Now to do it in basic solution, it's just one extra step. So let's do number 5A, which we had been doing in class